All right, so this is the third installment of our beginner track tutorial for building an RPG. And today we're going to be going over the inventory as well as the UI. And Faustine and I are going to be presenting this tutorial. So we have two goals for inventory, is to be able to set up a management system and have a concept of how to actively display information in the UI. And if we have time at the end, we can also go over the integration with combat. Right. We will update the GitHub README as soon as possible. And at this point, you can open Unity. Now, let me share my screen for that. So if you open up the skeleton package, you're likely greeted with an empty screen. There's a lot of files on here because this is the third installment and there's a collection of 3 tutorials worth of stuff. So just to navigate things, combat scripts are for combat. We're going to be possibly accessing only one of these scripts. You do not have to worry about images and fonts. The biggest things that you need to worry about is the inventory scripts folder, which has most of the logic that we will be editing, and the items folder, just to show the scriptable objects that we will be accessing in a bit. In the Pokemon scenes folder, you'll see 4 files. Now, what we want to do is go to the UI scene. So in this scene, we have a basic inventory that's implemented here as a prefab. And currently, this is all blank. We'll be displaying information on this UI in our scripts. So now I navigate to the inventory scripts folder, and we'll begin by exploring how the inventory system would work. Open this inventory item script. And let me share my screen. All right, so in these scripts, we have provided some skeleton code that we'll be filling in throughout this tutorial. And for this inventory item class, the most notable point is that this is a scriptable object. Now, you may notice that in, say, like the inventory script, everything will be mono behavior, and that's the Unity default. What scriptable object does is it allows your code to be active in the assets folder, which is very useful for us because we can display large amounts of information pretty easily, which is what we're going to be doing for the items. So we have some variables here. The serialized field makes it so that it will show up, this variable will show up in the Unity editor. And this text area will mean that the variable can be edited within a text box in the Unity editor. So to briefly introduce some of these variables, ID name is the name that we'll be potentially referencing in the script. It is good practice to have a name that you refer to in your script to all of the items that you have, so that if you want to edit the way that it's displayed, you just edit display name. So this way, if you want to change your item's name, you only have to change the display name, and in your script, you would not reference this unless you're displaying the item. This way you can keep a good workflow. The tooltip is a brief description of what the item does. The icon is what will be displayed on the UI. And heal power is what we will be using potentially to integrate with combat. This is the amount of healing this will do to the Pokemon. Now, under this public class, we have some predefined getter functions, which just return the variables. Now, it's always good practice to have these getter functions. So even though this seems like you're just doing extra work, this is good practice. So now we have a to-do here. Now, throughout this tutorial, there will be many other to-dos, and this is where you would have to fill in some code. So this to-do says there's a way to easily create scriptable objects by writing something. And I'll be revealing to you what that is. There's a thing that we can do with scriptable objects called create asset menu, which basically makes it so that you can create scriptable objects from right click using the Unity editor. So in here, we want to do, give me a brief moment. So file name equals, no, we'll say item here. So what the file name does is this is the default name that your scriptable object will be initialized as. And then comma menu name. Oops, I can't spell. And we'll do scriptable objects / inventory item. And then we're going to do order equals 1. What's this? So now if we save this code and go back to the Unity editor, now if you right click in this editor, hover over create, you should be able to see this scriptable objects icon. And if you hover over that, you can see that inventory item is in here. If you click this, it will initialize a default scriptable object named item, which we defined in the function. And we're going to delete this because we don't really need this right now. And for good organization, put all of your scriptable objects in this items folder. So here we have some predefined inventory items that have ID names, display names, and tooltips all filled out. Feel free to make your own. This is where you can get kind of creative. As you can see, I'm not very creative, so I made some very dumb looking tooltips. But we will move on to the inventory script. All right, so in this inventory script, this is where we'll be controlling the inventory items that we just defined previously. The main function of the script is to hold this dictionary, which maps an integer to an inventory item. So what this does is basically we have the inventory item as the key and the amount of it as an integer. Now, the static inventory instance, as well as the code in this awake, just makes this inventory a singleton. You do not have to worry about this. This just means that only one inventory can be initialized or instantiated in a given scene. So you may notice that this inventory has not been initialized. So we have to actually create the dictionary for the inventory here. All right, now that that's done, to briefly explain, this add all function is used for debugging purposes. This will add one of each inventory item in the assets folder. This tutorial will not cover how you would gain more inventory items. That would be the next tutorial, which is the shop. So currently we're going to be using this code, this script to test our inventory by filling it up. But the add item function is not currently implemented. So what we need to do is add an item to the dictionary, and if it already exists, increment the value by 1. So let's do this real quick. So first, we need to check if this item is already in the inventory. If the inventory dot contains key, and then we'll do item. So what dot contains key does, it will search through a list of this inventory's dictionary's keys and return true if the parameter that's passed in is found. This means that if item exists in inventory. And what we'll do is inventory, then item, plus plus. And if this item didn't exist, now we'll define this new key. So if it exists, we'll increment the value by 1. If it doesn't, we'll define it and assign the value of 1 to it. All right, we'll follow a similar logic for remove item. It'll decrement the number by 1. And if that number reaches 0, we will we will remove the item from the dictionary. Oh, and this is a Boolean because if this item was not originally in the inventory, this will return false because you can't remove something that isn't in the inventory. Right, so this code should remove our item, our given item from the inventory and delete it if it no longer exists. Now with that, there are some extra functions in this inventory class. Namely, this function returns a dictionary with the ID name and the number of items in the inventory. We will not be using this very extensively in this tutorial, but this would be the use for the ID name if you need to reference this item from your scripts. And the bottom function here just returns a dictionary that maps the inventory item to the integer instead of the string to the integer from the previous function. All right, now that we have the inventory logic basically set up, let's move on to the UI display script. Now this script, when you open it up, it might look very scary because most of the logic for this tutorial is within the script, but we will take this step by step. So the first thing we want to do is to set up a scrolling system for the inventory, or sorry, to actually get the information from the inventory class. So if we go to the beginning of the tutorial, the serialized field right here that has inventory player, this would be referencing the inventory class, and we would have to pass in this inventory object from the Unity editor. The dictionary here is also passed in from the inventory class, and we'll be referencing this throughout the UI display script. And this list of inventory items is the list that we'll be using for the display. Since in our display, we are only going to be referencing the item itself and not the actual value, it is useful to have a list here just so that we can streamline the process of displaying the item later on. And finally, this integer called list size just tracks the size of this display list. So the first function that we want to fill in is this get inventory script, which is defined. Oh, sorry, I passed it. So this get inventory should update the local inventory dictionary, which is the dictionary that we set up here. So what we want to do is first pass in the player's dictionary. This player object, remember, is the inventory. And now what we need to do is add the items that we need to display into the display list and then remove any items from the display list that we no longer have. So for instance, this for each loop will search through the inventory. This for each loop will search through the inventory from the player and get all the items that are in it. And we'll need to add those items to the display list. All right, so what this group basically does is If the display list doesn't have the item, we'll add it to the display list and increment the size of the list. So now we must implement the opposite logic, basically. So if in our inventory, the player uses an item, that will no longer exist, right? So we have to remove that from the display list so we no longer display it. But before I copy the same code from down here, except remove, there is an issue. In this for each loop, we're looping through the inventory dictionary's keys, and then we're adding it to the display list. The difference up here is that in this for each loop, we're looping through the display list. And what we want to do here is directly edit this list. So this will cause an error because as the for each loop loops through the same list, we can't edit it. Otherwise, the program will not like it in stream. So to fix this, we need to define another list, which I'll just call kill list because we're going to be killing the stuff in it. List of inventory items. And with this list, we're just going to be adding items that we want to remove into the kill list. And down here, we'll add another for each loop that will loop through the kill list. All right, so hopefully that was pretty clear. But basically in the first for each loop, we put all the items that we want to delete into this kill list. And then in the next for each loop, we'll loop through the kill list and remove items from the display list. This way, we're never modifying the list that we are looping over. So now Unity will be happy. All right, so now this get inventory function is fully set up. We will now talk about how we're going to display this. For that, I'm going to need the slides again. All right, so to briefly explain the concept of the UI, we'll have our list of inventory items, remember, in our display list, but they won't fit on one screen. So the solution is to define a region to display our UI. And we'll define the top boundary of this region as the disp index variable. So now we'll need a cursor to navigate this inventory, and let's define that for this cursor's position, called cursor pause. So this would be relative to the display window, which means that cursor pause will only go from 0 to 2. So 0 being up top and 2 being on the bottom. This cursor should be able to move freely within the window. And once it moves out of the range, it should drag the display window with it. All right, after that brief explanation, let's try to implement that. So back in the UI display script, in this update function, you might notice some logic here. So this if input get key down basically says that if you press the down arrow, it'll move the cursor down. And if you press the up arrow, it moves it upwards. let's go to the cursor's definition here. So now we'll have to implement this. What this basically is that if the cursor is at the bottom of the screen, shift the screen downwards. And otherwise, if it's not, then shift the cursor only. All right, so for a brief explanation, the shift display down is another function that we will implement. And what this does is it'll shift the display window down, which we just talked about will be represented by this disp index. And so what this second part of the if statement means is, remember that list size determines the size of our display list. So what this means is if the disp index, which is the first index of our window, and that plus the cursor position, plus 1 because we're moving this cursor down, if that exceeds this list size, we shouldn't be able to update the cursor position. Otherwise, we would be moving out of the screen. Now let's implement the similar logic for the moving up part of the script. So if this cursor position equals 0, remember this is the topmost slot, we'll attempt to shift the screen up. And if we're not shifting the screen up, we'll decrement the cursor's position, which will move it upwards. All right, now let's implement the display shift. So shifting the display works in a similar fashion to how we shift the cursor. Let's start with moving the display upwards down here. So what this means is if subtracting 1 from the display index will be less than 0, this means that we're moving outside of the range of the display list. So we don't want to do that. That's where return false. Otherwise, we can shift our display upwards and return true. Now for shifting downwards. Since we're moving down, we would have to deal with the lower boundary of our display list. So if shifting the screen down will go past the last item slot, we can't shift down, thus returning false. Otherwise, we'll do the normal logic of shifting and returning true. Now notice that this is list size -2 because the display index represents the topmost slot of our display window, which means that for this display, we're displaying 3 slots at a time. So we need to subtract 2 from here. All right, now we have fully developed the shift display down function. Thus, our move cursor down function would also work. And the next step is to display the actual items in our inventory, which I'll hand over to Faustine. Let me pull the changes.
All right.
All right, I'm pushing the changes to the skeleton demo branch.
Okay. All right, then hello. Now that we have implemented the inventory logic, we can display the needed info for our users to see them. And currently in our hierarchy here on the left side, in the skeleton, we have our prefab, which contains the inventory, which has basically like the script for the inventory on it, and the UI manager, which is responsible for just controlling, turning on and off the inventory canvas. And the canvas is like the actual UI where the buttons or the text and images and things will be displayed to. Yeah, and here we also have just like what is on the canvas. So you can kind of see, like, we turn this on, you'll see what we currently have set up. So we have the empty kind of inventory slots where we can put our item names onto. Another text box over here where we can display the tooltip of each item. An image here, which is a child of like an image parent, so that it can conform to the size of this box, no matter how big the image is. And we will be displaying the item sprites here as well. And we just have a little title for the bag here. Yeah, so that's kind of just what we currently have set up in the prefab and what we will be using in our scripts. Okay, and if we go to inventory scripts and UI display, on my screen. Let me switch my screen to Visual Studio. Sorry, just pause here as it loads. Okay, let me switch my screen to Visual Studio. Okay, and now we're in the UI display script, which is what Min used as well to get the inventory and the items and information necessary for us to display it onto our canvas. And here at the top, we have some variables that we'll be using. So this serialized field is called set number. So that is basically the number of items that will be displayed on screen at once. And for us, it is 3. In this field, we'll have the scroll bar, which will serve as kind of just a visual for how far down the list we are at. And we're also going to have a actions panel that we will show like what the items can do. And after that, we also need a field for the image and also the tooltip, which we'll be referencing for us to update it with the item information. Okay, yeah, and we also want to have the item that is currently being selected. Okay, so we can start with this function called render display. So go to the definition. Oh, okay, all right. Okay, so here we're at render display, which basically is responsible for displaying the inventory slots, the names in the inventory slots, and showing the image, kind of just like showing a visual for when the inventory is being displayed, being selected by the cursor, and also showing the item sprite and tooltip onto the canvas, as well as setting the scroll bar over here. Okay. And okay, we can, it seems like, wait, edits didn't go through, but we can just walk through this, I guess. So the first thing that we need to do here is for each item that is on screen, we want to display its name. And here we use a for loop that starts from 0 and ends before the set number, because in one display, we start from the count, the index 0 up to 2, and our set number is 3. So we want to display loop through 0 to 2 and display each item's name. And under display item name, we have its order. And basically the order is the index of the inventory slot on screen. So basically, if we look at, let me also switch my screen. So the topmost item, as Ming went over, will be 0, and the one in the middle is 1, and the one at the bottom is 2. So the order is basically their index here. So that variable corresponds to that. And here we have an if-else statement. And so display index plus the order is basically what which number the item is at in the actual list. So the display index also goes from 0 to the list size minus the number of items on screen. So each item is basically the index that it is corresponding to is the display index plus its index on screen. So essentially right now we're getting the, So for this part of the code, we want to find the corresponding item with its index and then display the text, its tooltip, its name onto the screen. And inventory slots order here gets the image on screen, and then get component and children. Basically each image on screen has a text associated with it, and we want to update the text under it. Once we get the text that is associated with the image on screen, we want to display the name of the item by getting the item through its index and getting its display name. As Ming mentioned, we're using its display name instead of its name that is being used within the code. And if the item index is bigger than the size of the list, we set the inventory slot to being blank. Basically, we don't show anything there. Yeah. Okay, so that is what display item name does. And after that, we want to basically change the transparency of each item slot in order to show where the cursor is currently pointing to. So we start by setting everything to being half transparent. The color class basically is, it sets the colors with the red, green, blue, and alpha values. And alpha is basically the transparency of a color. So we don't want to change like the color of the slot. So we just do image.color .r and take its original RGB values and just change that to half transparent. And we do that for each image in the inventory slot. Slots. After we've done that, we get the inventory slot that is currently being selected by the cursor and set that color to being just opaque, so that it is the one that shows up as being opaque and being selected compared to the other ones. And after that, we basically want to display the icon or the image that is corresponding to the image item to this UI that is on screen. And we also want to display the tooltip corresponding to the item to the text on screen. And we first get the item selected by getting the item on the cursor. This is another function here, which basically returns an item, the item on the cursor. And we want to, so basically what we need to do over here is, oh yeah, no worries. Yeah, some of my skeleton code got overwritten, so I'm just kind of going over it like this, but it's okay. Yeah. So basically here with the get item on cursor, we want to return the item that is currently being selected. So by adding the display index to the cursor position, we are able to get the selected item. Yeah, you can imagine like the index for what is currently displayed, adding to like starting from 0, 1, and 2. By adding them together, you basically get the item that is, as I said, currently being selected. And by returning that, we also set the item selected to what is being returned. If you remember at the top, we defined this variable as a inventory item over here. Once we have that, we will use the get functions under the inventory item to get the image and also the text. And notice that we have the image item icon, but also dot sprite, because only then can you take in images and taking sprites to set it. And we're also doing tooltip.text to take in actual text as well. And we use a try catch statement here in order to catch the exceptions that may come from having, say, no item being displayed, or if me can explain this better. Yeah.
So for this part, the idea is that we kind of know that the error is going to be caused by the inventory being blank, because the get item on cursor and all the code that's after that is based on a return function that straight up attempts to get an item from the display list. We're not too sure about all the errors that may occur here, but we know that it is because the inventory is empty. So with try catch statements, you would usually want to catch a specific error or a specific exception. So currently this is not good practice to catch everything, but since right here we're not too sure which errors are going to arise, but we are sure that it's caused by the inventory being empty, we use a blank catch statement and put the alternative code in the catch statement that would handle the case of the inventory being empty.
Yeah, and when the inventory is empty, we would like to set everything to default blank, default blank display, or just something that displays when there's no item. So we just set the item icon .sprite to null so that there isn't any sprite in there, and the text you can do whatever here, just like a default message for when there is no item. Yeah, and basically here, because there is no item, you can't really turn on the actions panel. So we don't really go over this yet, but for the other actions, if you press the space bar, an actions panel should open. But because we don't have an item here, it should always be false. So even if the user tries to turn it on, it won't. Okay. Yeah, if doing something, just don't. And after that, we want to set the scroll bar to show a visual for how far down the inventory we are at. Okay. So now that we have gone over that, we can talk more about the set scroll bar function. So currently the scroll bar doesn't actually, is not interactable. So in Unity, scroll bars can be used to scroll through things, but because we used our system of scrolling, we just it is just there for a visual indicator for how far down the list we are. And so as kind of a brief explanation here for how the scroll bar works. So for the total number of items in our inventory, for each increase in one item beyond just like the initial 3 or the initial amount of items possible that can be displayed on the screen, a new set of possible items it basically adds a new set of possible items that can be displayed on the screen, if that makes sense. So basically beyond 3, if you add another item, now there are two sets of items possible that can be displayed on the screen. And that means the indices for that would be 0 and 1. And if you add another item, that means there would be 3 sets of possible items that can be displayed on the screen. And the indices would go from 0 to 2. And we can walk through this more. It's a little confusing at first, but we can look at the code as well. And basically for the actual scroll bar, because it basically is set from 0 to 1, and we want it to display one set out of all of these possible sets that can be displayed on the screen. And for example, if we have 3 sets of items that could possibly be displayed, you would want to go from 0 out of 3 to 1/3, 2/3 to 3/3 for each corresponding set. So basically the scroll bar represents one set out of the total sets possible. And as mentioned here, for each additional item added, the total sets possible increases by 1. Okay. So the actual code looks like this. So it is for in the actual, okay, so yeah, we want to make sure the scroll bar is uninteractable because we're doing it independently to what the scroll bar is doing. But okay, so here we set an integer set number equals 3. So every set of possible items on screen has 3 items at a time. Yeah, let's change that to items to make sure we're using the same terms. And the set count is basically just the count for the number of sets possible. Let me also change that to maybe set index to make sure it's clearer, because we start at 0 instead of 1. So this would be list size minus the set number, or the number of items in a set. So that is set index would be the list size minus the set number. So we can go back to the slideshow. So for example, here we have 6 items, and the total number of sets possible would be so 1. Let me see if I can draw. I don't think I can. Okay, anyways, so the total number of sets on screen possible is so 1, so potion, hyper potion, potion, and max potion. 2, hyper potion, max potion, donut. 3, max potion, donut, edible sword. And 4, donut, edible sword, and big donut. Okay, so we counted 1, 2, 3, and 4 sets. And that would correspond to the indices 0, 1, 2, and 3. And so the list size is 6, and the initial, so the number of items in one set is 3. So what you can do is subtract 3 from the list size to get the biggest possible index, which is 3. So we have 6 items minus 3 equals 3. And this also works for other numbers, like if you want 4 items on screen and you have a total of 7 items, 7 minus 4 equals 3. That's also the biggest index possible. Yeah, so the logic there is a little, yeah, you definitely let us know if you have questions about that. But we're gonna move on to explaining the rest of the code. Yeah, so in addition to that, if say the list size is smaller than the possible, so every set, so like if you can have 3 items on screen at a time, but you only have 2 items, you want to make sure that you set the set index to 1 instead of having like a negative number or a 0. So because if the list size is smaller than 3, there is only 1 set possible. So the scroll bar would like be just 1. Okay, and after that, we want to set the handle size. So the handle on the scroll bar should represent 1 set out of the total number of sets. So this is the 1 set that the handle is representing, and the set index would be just the total, like the max possible number of sets. And after we do that, we want to make sure that we actually set the scroll bar to be that handle size. And the handle value should be the display index times the handle size. So each display index is also just like 1 set out of the total number of sets of items that can be displayed. So if you multiply that by the handle size, it will be how far the handle should go for the current display. Say, for example, let's see, let me go back to the slideshow. So say you are in, oh no. Never mind, the Google logged me out, but basically, yeah, so if you multiply the display index by the handle size, you will get to how far the handle should go for each display. And yeah, that's a little bit a lot to take in for like setting the scroll bar. So let us know if you have questions about that. And that is also just for a visual indicator. So yeah. And the last thing that we would like to cover is basically the actions panel. In our inventory, we have a panel here that is currently disabled, but you can enable it like that. And it basically just displays the items, the actions that each item can do. And we can add some text boxes to show what they should be. Say action 1 and you can, here's a little sneak peek at what Text Mesh Pro is, like how to edit the text here. So you can set the text color and also the font from font asset and vertex color, and also the font size. And you can also alter the alignment from the settings over here. And what I'm going to write here is just use, and let me just copy this one over so that we have the same formatting and things like that. And the second action that we want is, okay. Yeah, so that is basically our actions panel. Yeah, and make sure that we're using, and as a side note, we're using Text Mesh Pro instead of just normal text, just for these extra things and for it to look better. Yeah. Okay. All right. So currently, before I enabled it, it was disabled. And we want to do it so that the user can enable and disable the actions panel. And here we have just get key down action key. And we set this one to be the space bar. But because we have it as a serialized field over here, you can also change that from the editor. And so if that key is pressed down, we set the Boolean actions on to not actions on. So if it was true, it would be false. And if it was false, it would be true. So that in effect acts as a toggle. And we just set the actions panel to correspond to that Boolean for it to be toggleable. And here we just have the actions that we would like to implement over here. And the system that we're using is just numbers. And for if you press 1, it will use the item. And if you press 2, it will drop the item. And we would like to put in some code over here. I was wondering, Ming, would we like to do that in this tutorial or?
I think we have enough time. So yeah, I can take over for that part.
Okay, sounds good. And yeah, we after each action, we'll just update the inventory as well and render the display corresponding to what it should be. Yeah. Okay. And I think that is most of what we would like to cover. And I think in the UI control script, okay, we should also cover this. This basically is a script that just toggles the UI or the inventory on and off. And it takes the canvas component of the canvas as you've seen in the game and just disables the canvas component instead of the entire the object, because just by disabling the canvas, you are able to turn off the UI components. And we also get the UI display script, which we would also toggle on and off as the canvas, as the inventory is opened and closed. And we have a Boolean here to determine whether the inventory is being enabled. Okay, and in the update function, which updates each frame, it would, when we get the key that toggles the canvas, this one's also a key code over here. Currently, we are using C, and we are able to toggle the inventory. We call the function toggle. And under toggle, we basically set the canvas enable to the opposite of what it currently is, like we've seen for the actions panel, for it to swap between true and false. And if it is currently enabled, time.timescale would be 0, which basically just pauses and stops everything that is affected by time. So say if a character is moving, they would not be able to move if the time scale is 0. Basically what this does is if the inventory is on, it kind of acts like a pause screen and everything would just pause for that for a while the inventory is open. And we would just set the canvas component and the UI display component, which is basically this script, to the Boolean canvas enabled. So that would be true or false, depending on the toggle. Yeah. Okay. I think that's it for me. And I'll also push this again.
All right, so we have about 15 minutes left, and we'll go over briefly how to integrate with the combat. All right, so for this section, we're going to be attempting to integrate this UI with the combat. So in your Unity editor, go to Pokemon scenes and open up the combat scene. Now in this scene, you should see that there is an inventory UI prefab already placed in here. We'll be using that shortly. But as of right now, if you hit play, this is what was covered in the tutorial and the first part of the RPG series. So we can choose our options with the up and down arrows and use space to confirm. So if we're going to fight, and then use the left or right arrows to choose the move, Hydro Pump, and that'll do damage, and the opponent will try to kill us. But right now, if we click the bag option, you guys can't hear it, but I'm spamming my space key and it doesn't do anything. So we're going to make that work. All right, now navigate to the UI display file, and I will reshare my screen. All right, so now we navigate to the UI display script. And what we need to do is go to the render display section. No, we go to the action panel toggle section where we had the if actions on and input.get key down with the alpha 1 and alpha 2 here. This is a section where we can use the items. So currently the idea is to have action 1 be to use the item, which would communicate with the battle scene to heal the Pokemon that's currently on the screen. Whereas action 2 just drops the item. So let's start with the easy one first. This action 2 will, both actions will update the inventory right after an action, and this one will drop the item. Now to implement this, we have a helper function down below, which is drop item. So here, this should be super simple. All we need to do is delete an item, which is just dot remove item. And return. Okay, and now we reference this in this action 2 section. Okay, so with the script, when the 2 button is pressed, the currently selected item will be dropped and the inventory will be updated. So before we implement action 1, there's a few things that needs to happen. So first, we need to go to the battle system code. This is the code that controls the battle system. And the idea is we need to communicate with this code somehow. Let me scroll to the right place. So we need to communicate with UI display from battle system about the heal power of the item that's used in this section. So here with use item, we're going to be removing an item like we did with drop item. But the only difference is here we need to somehow communicate with battle system that we removed an item. And to do that, we need to reference a function. So in UI display, we have to do game object dot find object of type. And in here, we want to use battle system. Okay, so this will look through the scene to find an object that has the battle system type on it, which in this scene should only be one object. And since we have that reference, we need to do dot item heal. All right, right now this item heal function isn't properly implemented, but this function will allow us to call this battle system script and activate this function. So let's go here and implement the item heal. So in here, we need to set a local variable to the heal power that's passed in and communicate that an item has been received. To do that, we need to go to the very beginning of the script. And here I commented a to-do. So up top, we need to define a few variables, which would be so we need an integer for the heal power. And we need a Boolean that will tell us that an item has been selected. So let's initialize these to some dummy values. Okay. And now one key thing is that we need to somehow reference this UI script. So here, we also need to define a UI display object and name it UI. So here in the start method, a variable needs to be assigned, and this variable would be the UI. So here we would have to, oh wait, we would need to do serialize field, get component, and then UI display. So now, now that we have this all set up, we can go back down to the scripts that we need to edit. All right, so a brief, I guess, refresher on how this update system works. The battle system uses a series of phases. So in the update, it'll call the appropriate phase and switch phases as need be. So in the action select phase, there is a bunch of input handlers that will switch the phases appropriately. So what we have set up here is in this else if statement, this means when it says selected equals 1, this means it's selecting the bag option, if you could recall from a few minutes ago. And if this is activated, we need to set this to the appropriate phase for item selecting. And now down here, we have a case for the item select phase. So if an item was selected, we need to switch the phase back to action select, heal, and then switch off the UI. So what we need to do here is, instead of if true, we need to do if item selected. So remember, this function is in the update function. So item selected will be checked every frame. Now in here, we need to heal the Pokemon and toggle the UI. Which is currently giving an error. And this is because the UI controller has this detoggle script. So this is the UI controller class, and I mistakenly referenced the display class. So let's fix that real quick. Go back to the serialized field, change this to UI controller. All right, now the UI toggle should work. Finally, we need to change the phase back to actions, back to move select. Or actually, is this action select? Yes, we need to change it back to action select to the main menu that allows you to select either the bag or fight. All right, so now we have a heal Pokemon function that we need to implement. And this item heal function, remember that we need to use to communicate with the use item. So now that we define the two variables, that one of them stores the heal power and one of them is a Boolean that indicates if an item is selected, all we have to do is to set those. So we have to set heal power to the heal that is passed in. And item selected will equal true. So recall that if item selected is true in this item select phase, it'll switch it back to action select, heal, and then toggle the UI off. So this way we can finish the loop and go back to action select and choose to heal again if we want to. Finally, before we implement the heal Pokemon, let's complete the loop with the heal power and item selected variables. To do this, we need to go back to the action select phase. In this statement, we need to reset the two values, the heal power and the action and the item selected boolean, and then switch to phases and toggle on the UI. So we want to set the heal power back to 0 here. Set item selected false. Switch to phase to phases dot item select and do UI dot toggle. All right, so when we are in action select phase, once this key is pressed, the proper variables are reset and the phase is swapped and the UI is toggled on. So now all we need to do is set up this heal Pokemon function. All right, just a refresher from the first tutorial. This Hud script is the HUD for the player. So we won't be going too deep into that. So we already provided the code for this. This will set the HP bar on the screen to the current Pokemon HP. And all we have to do is increase the health of this Pokemon by the heal amount. And we have to cap it at 100. So we want to do Pokemon.health or HP plus equals heal amount. And remember, our healing can't go over 100, so let's use an if statement. If the HP is over 100, let's set it back to 100. All right, so now this function should work properly. And in this heal Pokemon function, we would need to pass in the proper parameters. So the current Pokemon, we want to pass in the player's Pokemon, which is the player. And then the Hud script is the player's HUD. And the heal amount is the heal power function that we defined previously. So now we save this, go back to UI display. This item heal is still having an error because we need to pass in the heal power of the item that we removed, which means we can't really remove the item yet. Have to remove that after this. So to get the heal power of the item, we just have to do item.get heal power. All right, now this all should theoretically work. So let's save all the scripts and go back to the Unity editor. Oh, yeah, and Richard, the code here, let me reshare this. Well, the code here should ensure that the HP wouldn't overflow. And I don't think there's a problem with the HP being temporarily above 100. It won't stay that way though. So this shouldn't be causing any issues. Okay, let's go back to the combat scene. Let's hope that this works. Let's fight a little bit. Okay, we need the Charizard to actually do some damage. All right, so Charizard's Fire Blast hit through our Protect, and we are a little bit low on health. If we click the bag option, oh, okay. Oh, right. Since we set the UI object in our code to a serialized field, we actually have to assign that. Yeah, the UI here, we need to assign that with the UI manager. And now, okay. Doesn't have that null reference. So if we double click that, are you sure? Okay, so UI toggle is still a null reference. So UI controller is set here. Which means it is possible that the UI manager or that may have objects that are not assigned. All right, so before we begin, there are a few things we need to address. First, by changing to the combat scene, some of the elements are no longer linked within this inventory UI. So navigate to the canvas, and underneath the UI display script, make sure that under inventory slots, you have these inventory M slot 1, 2, and 3 linked in here. You can just simply drag that in, and that will show up there. So yeah, without this, there will be a null reference exception. The second thing is I forgot that I forgot to hook up one of the functions that we've defined before. So navigate back to the UI display section, and under the action panel toggle, we need to actually call use item here. Now, if we go into bag, should be able to select a item, and if you press space and then press the 1 key, it should heal and return you back to the screen. So now let's check if it actually healed. So I'm gonna fight, and hopefully Charizard does some damage. So now Blastoise is hurt. Now we go back to the bag, and we're gonna eat a donut, and then press 1. So now once we go back, you can notice that Blastoise has been healed a little bit. Now we can go back to bag again, and sure, let's eat this sword, why not? And you can see that Blastoise's health is almost back to full. All right, so that concludes the basic implementation of the UI script into combat. And that concludes our tutorial. In the next week, we will be implementing the shop. And during that time, we'll learn how to actually add items into the UI. Thank you all very much for watching.